Hello friend, today we will discuss the question taken from CSIR UGC NET 2018 June, and the question taken from the booklet code A, and the question number is 47. And the question is the resolvent kernel for the integral equation phi x equal to x square plus integration over 0 to x e to the power t minus x phi t dt, okay, is e to the power t minus x 1 e to the power x minus t x square plus e to the power x minus t. Okay, so first of all, the given integral equation is this. Okay, so this is a Volterra integral equations of second kind. Okay, if we compare 1 with phi x equal to f of x plus lambda integration over a to x kxt phi t dt, then we get fx equal to x square, lambda equal to 1, a equal to 0, and kxt, that is e to the power t minus x. Okay, t minus x. Now we find the value of the resolvent kernel. Okay, to find the resolvent kernel, first of all we find the iterated kernel, and the iterated kernel is k1 of xt, this is kxt, and kn of xt, this is integration over t to x kxz kn minus 1 zt dz, and this is for n equal to 2 3 ... Okay, and the resolvent kernel is r of x t lambda, this is summation over lambda to the power n minus 1 km of xt m equal to 1 to infinity. Okay, this is the our formula. Okay, so in this question kxt is e to the power t minus x. Okay, so k1 of xt, this is e to the power t minus x, and k2 of xt, this is integration over t to x k of xz k1 of zt dz. Okay, this is integration over t to x, and k1 of xz, this is e to the power z minus of x, and k1 of zt, this is e to the power t minus z dz. This is integration over t to x e to the power t minus x dz. So this is e to the power t minus x integration over t to x dz. So this can be written as e to the power t minus x x minus t. Okay, this is k2 x minus t. Similarly, k3 x minus t, this is integration over t to x kxz and k2 zt dz. Okay, so integration over t to x k of xz, this is e to the power z minus x. and k2z is, since k2xt is e to the power t minus x, x minus ft, so k1 of zt is e to the power t minus z, z minus t dz. So this is integration over t to x e to the power t minus x, z minus t dz. So this can be written as integration over t to x, z minus of t dz. So this is e to the power t minus x, z minus t square by 2 tx. So this can be written as x minus t square by 2. Okay. Similarly, k4xt, this is e to the power t minus of x, x minus t cube by 3 factorial dot. Okay. So r of x t, here lambda, this is 1. So r of x t 1, this is summation 1 to the power m minus 1 km of xt, m equal to 1 to infinity. So this is nothing but k1 of xt plus k2 of xt dot, and this is e to the power t minus x, this is e to the power t minus of x, x minus of t, and then e to the power t minus of x, x minus t square by 2 factorial, then e to the power t minus x, x minus t cube by 3 factorial plus dot 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 dot. Okay, so this can be written as e to the power t minus x 1 plus x minus t, x minus t square by 2 factorial and dot dot dot. So this can be written as e to the power x minus of t, so that is e to the power 0 and 1. So this is our resolvent kernel. So r of x t 1, this is 1. Okay, so our answer is option 2. This is our correct action. Okay, answer. If you like the video, please subscribe this channel and share these videos, and also hit the bell icon. Okay, for new videos. Okay, tada.